Okay, so we gonna solve a problem today. That was our daily problem on 17th July. It's 19th July. This problem is coming from linked list. We have to add two numbers, and those numbers are not normal numbers, and this addition is not also a normal addition. These numbers are coming into linked list, and you have to add those linked list, and then you have to provide another linked list that would be representing some of previous two linked lists. So there might be different sort of ways to solve this problem. One very brute force solution would be, if you say one very brute force solution will be this. It will be like you take two stacks. Okay, you take two stacks. In that what you need to do, you take these two stacks. Okay, you iterate on the linked list. So in the first stack you will add 7 2 4 3. So in the stack you will see 3 will be on the top, then 4, then 2, and then 7 will be there. And the second stack you will have 4 6 and 5. So what you have to do, you have to traverse that stack. You don't need to do anything. You just add the top values of a stack until any of the stack is not empty. Either of the stack is not empty. Okay, so in that case you will have your stack like this. Okay, if I have to go through you will have your stack like this. You will have 4 2 or 3 and 7. Okay, I don't know what is the actual linked list. I'm just taking to random. Suppose 1 2 and 3 is there. So you have to take this top value and this top value of stack. You will add it, and you will add in a linked list. Okay, it's 5. Okay, then you will pop this out. You will pop this out. Then you will take this 2 and this 2, and you will add this here as 4. Okay, then you will take this 3 and this 3, and after popping this, actually you will have this 3 at top and this 3 at top. You will add again as 6, and you will add 6. Okay, then first stack will be empty. There will be nothing in this stack. So in that case you have to come out of the loop, and you have to check whether any of the stack have any values or not. In addition, you have to take care of some like a remainder as well, because there might be addition, like you are adding two numbers and that number are actually bigger than 10. Okay, in that case you have to take remainder, and that remainder will be adding to next sum. So you have to also do that. So it's just a way. Then you will take 7 here, and it's just a normal, a simple test case that I'm taking. Okay, and then all you need to do is you can reverse. Okay, you can reverse this, and by reversing that you will have 7 6 4 5, and that will be the like, sorry, you don't yeah, you have to reverse it, and then you will have 7 6 4 5. That will be your actual output. So in that case the complexity will be order of n, but order of max of like length of these two. So whatever is below the maximum length, that will be the time complexity. But the problem here is we are using one stack space, and that's why we will have space complexity as well with order of n, and that we don't want. Okay, so this solution is also possible, but we are not going to solve that way. Actually, when someone is going to ask you this question, no, so they don't want to solve you by using any extra space or something. Suppose you are in interview. Okay, you might solve it in a brute force manner. You will say this is my first solution. Then they will ask you, okay, what is the optimized solution? So for the optimized solution there are two ways. I'll be going first. First is, this question is more over a reversing a list. Actually, if someone is asking you this question, then they want to know whether you know how much linked list. Okay, whether you know all the concepts of linked list or not, whether you know how to reverse a list, or whether you know how we do operations on linked list. So they only want to know that. Okay, so if you see this linked list, so if you have to add from the last. Okay, the addition actually takes place in that manner. So you have to add these two, then these two, then these two, then these two. So you have to first reverse the list. You have to reverse the connections, and after reversing the connections, 3 to 4 to 2 to 7, this will be the first linked list, and the second linked list will be 4 to 6 to 5. Then you can add head to head. Okay, you can traverse over the list, and you can keep adding, and you can create one more linked list, and that linked list you will mark as an answer or something. So this is the actual solution. I'm going to show you here. So if you have, suppose, something like this, 1 2 3. Okay, in second one you have only 1. Suppose you have 9. Okay, so in an effective manner you have to add these two, 9 and 3. then you have to add 1 and 2. So what I'm asking you to do is you reverse this list. Okay, so now your linked list will be 3 to 2, then 2 to 1. Okay, and this will be 9 to 1. Okay, by doing that you can directly add, like if you are not reversing it, then you have to go add the last, then there you will add two numbers, like on both linked list you have to go to end. Okay, then you have to add those end nodes, then again you will traverse from the front, will go to second last, then this way you will do, and there you will have order of n square complexity, because for adding two nodes you are traversing n nodes, and there are actually n nodes. Okay, so n into n is n square. Okay, so this is not efficient way. So the efficient way is reverse the links of these linked lists. Okay, so now 3 to 1, 3 to 2 to 1 is one list, and 9 to 1 is second list. Okay, okay, so you have to add 3 and 9 now, so you will say it's 12, so you will say only 2, you will have one remainder. Now you will add that remainder to 2 plus 1 plus that remainder, that will be 1 plus 2 plus 1, that will be 4. So you will add, you will have, oh, sorry, okay, so likewise, yeah, you will have 4 here, then you will write 4 here, and okay, wait, actually pen is gone, I don't know where to. Okay, we are offline, we will try reconnecting. Actually I think my internet is not working, let me check it. Okay, okay, so in a while it will be connected, not an issue. Okay, so now you will have that one as a remainder, then that remainder will be added to 2 and 1, so your next output will be 4, so that 4 you will write here, and then you will add 1, then you will make the links 2 to 4, then 4 to 1, and then in the last you have to reverse this, because you are adding in a right manner, but you want your linked list to be read from front to back, not back to front. Okay, so this is our logic. Okay, I don't know why this is some problems there in the Wi-Fi. Okay, it's connected. Sorry about that. Okay, so we can later on, like in between we can code, and this will be getting connected. Okay, so this was our solution. Okay, so actually what we have to do now is we have to now reverse this list. Okay, so I have written this function reverse list. So the function of reversing this linked list will be, actually there are two ways, the one is iterative and second is recursive. So I'm going to write the recursive way, so I'll write the code and I'll explain you. Actually okay, it's came now. Okay, so I'll write the code and then I'll explain you how it is happening. Okay, and I don't know where to find the pen actually. Okay, leave it. Okay, so we have to reverse this list. Okay, suppose we have this list, so we have 7, 2, 4 and 3, so that 7, that head will be pointing to 7, so we will pass that list head to this reverse, so we will create 3 pointers. Okay, I'll tell you why. So suppose we have list node star current, and that current will be pointing to head. Okay, then you will have star previous, okay, prev, that will be pointing to null initially. Okay, and then you will have star, sorry about that, then you will have star next, and that will be pointing to null as of now. Okay, so there is 3 pointer, where in the scenario where these 3 pointer will be in the initial stage, the current will be somewhere here. Okay, prev will be here, and next will be also be somewhere pointing to null. Okay, so you will be here, you will, what you will do that you will do, the first step you will do is, okay, let me show, while current. Okay, let me write then. Okay, the first step you will do is you will break this connection. Okay, you will break this connection, and then you will reverse this connection. Okay, so before breaking that, you should track the list, your list. For that, but for that sake, like if you break this connection blindly, so you will lose this list. Okay, for that, first of all, you will try to store the original linked list. So you will do this next equal to current next, sorry, current next. By doing this, now you have this address, and now you can break this, connection. So now you will break the connection. So I'm writing here, break the connection. Okay, break the connection. Okay, you'll break the connection, then you will establish a new connection, establish reverse connection. Okay, now you will establish the reverse connection. For that, you will do this current next will equal to prev. Okay, so basically now your link will not be like this, your link will be like this somewhere here, and in the initial save1 next will be null because prev is null. Now you have to move further. For moving further, now this list, the first node is prepared. So what you will do is, you will do this prev equal to current. Okay, so now your previous pointer will be here, and you have to also update your current, so your current will be here. So you will do this current equal to next. Okay, so this is our idea, and by doing that, you will see you will be keep breaking all the connections that are there, and same time simultaneously you will add new connections reverse, like from backside. So when this loop will end, you will see 3 will be connected to 4, 4 will be connected to 2, and 2 will connected to 7, and likewise 7 will be connected to null. So you can see your links list is reverse, and at the end you have to pass, or you have to return the head. So your head will be 3, and at last your prev will be pointing at 3. Okay, so return prev. Okay, so I wanted to explain you on the whiteboard, but I don't know why it is not working actually. Okay, so we had this. Okay, we had this 1, 2 and 3. Okay, we had this. Okay, so what I'm saying is, you take your pointer C here, that is current. Okay, and prev here somewhere at null. Okay, at null. Okay, your P is here, and you will take also one pointer, suppose something like next. In initial it will also pointing to null. Okay, so in the first iteration, what we will do, we will try to keep track of, if the keep track of rest of the list. Okay, because we are going to break this bond. If we can directly break this bond, then we will lose this list. So we will do next equal to current next. Okay, C next, we will do this. Okay, by doing that, you can keep track of your rest of the list. Okay, and then what you will do, you will break this connection. For breaking that, you will say current next equal to C next equal to, suppose I'm saying N as next, C next equal to prev. By doing that, now this connection is breaked. And now 1 is pointing to this null. Okay, and the next step will be, you have to go to 2 from now. So you will say current equal to, prev equal to current, and current equal to next. So this was the first iteration. In this, what you did is, you break the connection, you establish a new connection, and the same thing, the same window, you shift one step further. So now your current will be here, your prev will be here, and your next will be here. So you will do this. Okay, so this is the actual way to wait 1 minute. Yeah, so this is the actual way to do that. So by doing that, you can reverse your list. Okay, after reversing that, you will pass. Okay, one more thing I have to tell. Okay, you are iterating this linked list until current is null. So at the last, when your current will be here, this list will be also be established, and your current will be pointing to null in the end, and this node will be pointed by prev. So you have to return prev as a head. Okay, so this was the actual end-to-end output. Okay, now you have to, okay, so we are not going to do brute force. Okay, okay, so now we have to add to these two lists, and then after adding that, we have to reverse this. list and pass it as an answer. Okay, so for reverse list we will create a head. Okay, list node star head, initially it will be null. Okay, and we will also create tail star tail, it will also be null. Okay, now what we will do is while L1 L2 and L1. Okay, before that I hope you remember you have to reverse your list. So L1 equal to reverse L1, sorry, and L2 equal to reverse L2. Okay, now you will have the reverse list, and now you have to go through that. Okay, and I have told you have to take a remainder int remainder for keeping track of whether there is sum is greater than 10 or not. Okay, so what you will do now is you will have int sum equal to, okay, you will add everything, L1 value, L1 value, okay, plus L2 value you will add. Okay, along with that you will add remainder. Okay, remainder. And now what you will check, if, okay, so here is a catch, and the catch is if your sum is now greater than 10, so you can't add put 10 in that node, you have to put 0 and you have to take remainder as 1. So if sum is greater than 9, basically greater than 9 means if it is 10 or 11 or something. Okay, so in that case your sum will be sum modulo I think if it is 10 then you have to add 0, so in that case you have to put sum modulo 10. Okay, and yeah, your remainder will be, okay, and your remainder will be I think 1, I guess, because yeah, it will be 1, because if it is greater than, yeah, actually sorry about that, if it is greater than 10, so it will be 1, and your sum will be, suppose your sum is not 12, so if your sum is 12, so you have to put there as 2 and you have to take remainder as 1. So if it is 12, so you will take remainder you will take remainder as 1, and you will divide, you will take modulo of sum by 10. If you know modulo property, then that is good. If you don't know, then you can go through ChatGPT or whatever you want. Okay, so by taking modulo of 12 with 10 will be 2, so by doing that you can have it. Okay, so now this was the sum part. Okay, this thing you have to add in the node, but the second thing is you have to establish a linked list as well. So we will check if, okay, if head is already, like, if head is not null, basically we have established some connections parallelly, then we will say this tail next equal to new node, new list node as sum. Okay, and you will say tail equal to tail next. Okay, but if you haven't stabilized any head, basically if your head is null and your tail is null, in that case you have to stabilize first that linked list. So else you will do this, you will do head equal to this thing, control plus C, control plus V. Okay, you will do this thing, and you will say tail equal to head. Okay, so this was actual thing. Okay, after doing that you will say, okay, my summation is done, we will proceed further. Then we will say L1 equal to L1 next, and we will say L2 equal to L2 next. Okay, by doing that you will shift one step further. Okay, so there is the case where, like, look at this case. So in that case we have only 3 nodes in the first and 4 nodes in the second, like 4 nodes in the first, 3 nodes in the second. So by doing that you can add up to only up to here, so this will be left. Okay, you have to add also, you have to add that in your consideration, you have to add that in your list. For that you have to again run a loop. Suppose the first list is very big, okay, the second list is running out of length, the first linked list is big. So what you will do is while, because better we are writing this, we can copy this code, it would be helpful. Okay, because same thing we will be doing. Control C, control V. Let me tell you. So while L1, okay, while L1 is there, so you will say your sum will be L1 value plus whatever will be the remainder, and wait, yeah, what will be the remainder you will add. Okay, and remember, notice one thing. If you add, suppose you have 5 here, so you will add 5 and 5, that will be 10, and then one remainder will be left, then one remainder will be added to 7, then your linked list will be not it will be 8 here. So you have to track that remainder whether your linked list is finished or not. Okay, you have to keep that remainder. So I have to tell one extra case as well. I'll tell, okay, so this will be your sum, and then you will do the same thing again. Then you will check whether head is there or not, because there might be a case your first linked list is null, if second linked list is there. Also they have mentioned that this is non-empty, so no need to do that. We directly can do this, like no need to write this thing. You can directly write it. Okay, let's go and write it directly. Okay, so just write this thing, because if it is non-empty, then there must be something. Okay, there must be some node. If even if one node is there, that is also sufficient. Okay, so why we are writing a redundant code? Okay, so this is the actual thing. Okay, and one more thing here, if this is not the case, then you have to do this thing as well, else remainder will be 0, because in some case if you turn out your remainder as 1, and in another case your remainder is even not 1, even then it will be showing it is 1. Okay, so you have to put this case as well, else remainder equal to 0. Okay, so now this was for first linked list. There might be condition where second linked list is very large, first is very small. In that case also you have to process that linked list too. You will do again the same thing, but only you have to change the linked list. Okay, so we will say only L2 and everything will be same, nothing will be changed. Okay, so this is the thing. Okay, this is the thing, L2 and L2. Okay, so I hope you are thinking it is done. Okay, we can return first of all we will reverse our head. So we will do this, we will reverse our tail. Okay, because from the tail we have to reverse, and your head will be this. Okay, and yeah, and your head will be this. Actually we have to reverse from the head, sorry, because it is starting from there, no. Okay, and I have to, if I have to tell you, okay, here, so yeah, here, so we will add these two, we will have 7, then we will have 0, then 7 will be our head, it will be our head. Okay, then and here will be our tail, and this list will like this link will be like this, and you have to reverse from here. Okay, from here, so you have to reverse from tail actually. So sorry about that mistake, you have to reverse from the tail. Okay, so you might think we can say, okay, head, return head, that's it. But there is a case that is left, that is we used to call edge case. That edge case is this. Okay, that edge case is this. Suppose you have 9, you have 5, you have 2. Okay, and you had only one node as 1, or suppose you had only 2 nodes as 1 and 5. Okay, 1 and 5. Okay, so you added this, so you will say 3 is here, you will add these 5 and 5, you will say 0 is here. Okay, you have say 0 is here. Okay, starting from 9 as well. Okay, you have 0 is here. Okay, leave it. Okay, then you will have remainder as 1. Okay, 0 and 3, you will add 1 here, there will be 10, you will add again 0 here, so that 1 is left, you will add this and you will leave. But you have to also add one node here, extra node here, that will be 1. This will be the answer. Okay, but in this code this thing will not be tackled. Okay, you have that those two linked list, this you will process these two first, in then you have the bigger linked list as first linked list, then you will go to this loop, you will process that, and you will have your sum as 0, because that is 10, so you will have your sum as 0, and then you will add only 0 there, and then you will returning it. So you have to keep track whether if your remainder is equal to, like after doing all the operations, if your remainder is 1, if remainder equal to 1, or remainder is equal to 1, sorry, then in that case also you have to add that node, you have to add one more node as remainder. Okay, then c equal to b, and you have to add remainder here, because that is that is the thing that needs to be also added, because we can't add double digit. Can have only one digit. So this will be the actual code. So let me run this. I hope this will run. Maybe some error will be there. So actually I'm a beginner. Okay, this is saying head current equal to head. Okay, in line number 14. Okay, some error is there. Okay, this would be actually L1. Okay. Okay. Oh, sorry. You should go here. Okay. Actually, I'm a deep learning engineer. I'm working on Python from last 6 to 7 months. I haven't. I have okay. Your output is 7, and this would be like this. Okay. Okay. Let's check what is this. Okay. So passing your tail. Okay. That will be there. Okay. So come here. What we are doing is we have this 2, then 5, then 9. Okay, then our okay list will be, we have 7, then we'll have our header here, and we will have our tail here. So we have to reverse this way. Okay, this way, then this way, then this way. Okay, so we have to actually pass our head, because the head is starting, the link is establishing from there. Sorry about that. This was the actual problem. Okay, now it will be okay. Okay, so I can submit it. Okay, so this is a pretty long code. You can say 72 lines are there. Actually this I did it because I wanted you to understand. Okay, so this was end-to-end video. You can say it, you can refer it. It is like whole code is there, but I would say, I would recommend you, though there is one more way, that is that is not really practicable in interviews, because that is kind of trick, and interviews usually they want to check your knowledge, not your tricks. So the trick is, I'm telling you, that is, you convert this thing as a number, you also convert this thing as a number, and you try to add these things, and just again convert that number into a list. So what I am writing here is the actual same logic. You have someone and some 2. You just try to add some I is basically someone, and some 2 depending on someone, and some 2. So some I will be, if you will start from here, so some I into 10 plus node value. So if I have to dry run this, so some I, suppose someone is some I someone. Okay, some I basically some is either, it could be someone or some 2. It is for both. Okay, so this 7 initially, some I will be 0, you will be at 7, so you will multiply 0 into 10 will be 0, and node value will be 7, then your sum will, someone will be 7. When you will be here, your sum will be 7, then you will multiply 10, that will be 70, and then you will add your node value, that will be 72. When you will be here, you will be having your sum I is 72, you will multiply that with 10, that will be 720, and then you will add 4 there. Then you when you will be here, you will have 7 to 4 as your sum I, then you will multiply by 10, then you will have 7 to 40, like you will have 7240. Then you will add 3. By that you will have someone as this, and some 2 as this, and then you will have some total sum, that will be this. Add these two. Now extract this number from this number, extract each digit and convert that into a list. So what you have to do is, you have to just make one tail and one head, then know some basically number. Okay, you can say number, from the very last you have to extract numbers. So if you divide by if you take a modulo of this thing by 10, then you will have the very last significant digit. Okay, that will be 7. So that will be, this will be giving 7. Okay, so you will have 7, and again if you divide this thing by then you have to divide the whole thing, whole number will be sum total will be, sum total will be divided by, equal to divided by 10. So you will have not actually 7807, you will have only 780. Then you will again do this thing, then you will again have 0. So you will keep adding that into a node, and you will keep updating that node. So by doing that you can do this, but it is not really good practice. I would recommend you, because in an interview they would be like, I want to check your if they are asking question from linked list, then actually they want to check your knowledge from linked list. Actually they don't want to check your tricks and all. You might impress them. Okay, maybe after telling the actual solution that I've told you, you can tell this solution as well. They that might be impression you can left over there. but I don't think going like initially, if you're starting with this, it's not better. Even if you start with that stack solution that I've told you earlier, that is also good. That is actually actual brute force that you should tell. Okay, that if you are in an interview, you should always, if you have only 30-minute interview or 40-minute interview, then you have to analyze whether they are in hurry or what. So you have to be attentive. But if it's a long interview of 1 hour interview and they are going to ask you only coding question, you can easily go through brute force and all. If that is a fast track interview, like these days companies don't have time, so I had been there in the interviews where only 30 minutes they were providing, and they were asking some coding question. Again, they were asking some CS fundamentals like DBMS hoops and operating systems and all. So in that, you can't go through brute force and all. You have to give the accurate answer, and even in that case, they will not ask you to write the question. So write the code. Okay, thank you so much. Signing off. I'll again be coming with some other daily problem. I solved this problem because I find it very like not very challenging, but bit interesting, because uh, you are solving a tricky question or you are solving a tough question, that is different thing. But this question have a lot of implementation. Okay, you have to implement a English by your own, you have to add a function that will reverse that, then you have to keep track of all these things. So this was actually a good question. It is marked at medium on LeetCode, and it is actually a good question. Okay, thank you so much.